Industrial Control Systems, or ICS, and Supervisory Control and Data Acquisition Systems, known as SCADA, are the backbone of our modern world. They manage critical infrastructure, which includes power grids, water treatment plants, and manufacturing facilities. These systems are essential for our daily lives. However, this reliance on ICS SCADA also makes them attractive targets. Cyber attacks on these systems can have devastating consequences. Disruptions to power grids or water supplies can impact millions. Protecting these systems is not just about data security, it's about national security and public safety. The threat is real. Cyber criminals are becoming more sophisticated. They are increasingly targeting ICS SCADA systems for sabotage, espionage, or financial gain. We must act now to strengthen our defenses. This means understanding the unique challenges of ICS SCADA cybersecurity. It also means implementing robust security measures and adhering to industry best practices. The time to act is now. In the world of cybersecurity, the CIA triad is fundamental. It stands for confidentiality, integrity, and availability. These three principles are crucial for protecting ICS SCADA systems. Confidentiality means keeping sensitive data secret. This includes operational data, system configurations, and network architecture. Unauthorized access to this information can be disastrous. It could allow attackers to disrupt operations or steal valuable intellectual property. Integrity ensures that data remains accurate and unaltered. ICS SCADA systems rely on accurate data for safe and efficient operation. Tampering with this data can have serious consequences. Imagine a scenario where sensor readings are manipulated, leading to incorrect decisions and potential disasters. Availability means ensuring that systems and data are accessible when needed. ICS SCADA systems often operate continuously. Any downtime can disrupt critical services and have significant economic impacts. Attackers may attempt to disrupt availability through denial of service attacks or by disabling critical components. Protecting the CIA triad within ICS SCADA environments requires a multi-layered approach. This includes technical controls, strong policies and procedures, and ongoing employee training. To counter cyber threats to ICS SCADA systems, we need established security standards. Two organizations provide frameworks for this purpose: NIST and the ISA, in collaboration with the IEC. NIST develops and promotes cybersecurity standards. Their NIST SP 800-82 addresses ICS security. ISA IEC 62443 provides a framework for securing industrial systems. Adhering to these standards establishes a strong security posture. Implementing NIST SP 800-82 and ISA IEC 62443 reduces cyber attack risks. Let's take a closer look at NIST SP 800-82. This document is a vital resource for anyone involved in ICS security. It provides practical guidance on how to assess risks, implement security controls, and manage the unique challenges of protecting these systems. One of the key aspects of NIST SP 800-82 is its focus on risk management. It emphasizes the importance of identifying critical assets, understanding potential threats and vulnerabilities, and implementing appropriate safeguards. This risk-based approach ensures that security measures are tailored to the specific needs of each organization and system. The standard also provides detailed recommendations on security architectures for ICS environments. It covers topics such as network segmentation, access control, and intrusion detection and prevention. By following these recommendations, organizations can create a layered defense that makes it much harder for attackers to compromise their systems. Moreover, NIST SP 800-82 addresses the importance of incident response. It provides guidance on how to develop and test incident response plans, ensuring that organizations can effectively detect, respond to, and recover from security incidents. By adopting and implementing the recommendations outlined in NIST SP 800-82, organizations can significantly enhance their ICS security posture. Exploring ISA/IEC 62443 for industrial automation. The ISA IEC 62443 standards provide a framework for securing industrial automation and control systems. They cover risk assessment, system design, secure product development, and supply chain management. A key strength is its holistic approach, addressing both technical and organizational aspects. The standards introduce zones and conduits to segment networks and limit security breaches. Adopting these standards helps establish a strong security foundation for industrial systems. Section 6. Building a secure ICS network, segmentation and more. Securing ICS networks requires a multi-layered approach, and network segmentation is a fundamental element of this strategy. By dividing the network into smaller, isolated segments, organizations can limit the impact of a security breach. Imagine a castle with multiple layers of walls and gates. Each layer acts as a barrier, preventing attackers from easily gaining access to the most critical areas. Similarly, network segmentation in ICS environments creates zones with varying levels of security, protecting sensitive systems and data from unauthorized access. Firewalls play a crucial role in enforcing network segmentation. They act as gatekeepers, controlling the flow of traffic between different segments based on predefined rules. By carefully configuring firewalls, organizations can restrict access to critical systems, preventing unauthorized communication and potential attacks. Intrusion detection and prevention systems, or IDPS, provide an additional layer of protection. They monitor network traffic for suspicious activity, alerting administrators to potential threats and even blocking malicious traffic in real time. By implementing these and other network security measures, organizations can significantly enhance the security of their ICS environments, making it much harder for attackers to compromise critical systems. Section 7. Endpoint security, shielding the core of ICS. While securing the network perimeter is essential, we can't forget about endpoint security. Endpoints in ICS environments such as programmable logic controllers or PLCs, human-machine interfaces or HMIs, and engineering workstations are often the target of attacks. Protecting these devices is crucial for maintaining the integrity and availability of critical operations. One effective endpoint security measure is to harden devices. This involves disabling unnecessary services and protocols, configuring strong passwords, and applying security patches promptly. By minimizing the attack surface, we make it more difficult for attackers to exploit vulnerabilities. Anti-malware software tailored for ICS environments is also essential. Traditional antivirus solutions may not be suitable for these specialized systems. ICS-specific anti-malware can detect and remove malware designed to target industrial control systems, providing an additional layer of protection. Regularly monitoring and logging endpoint activity is another critical aspect of endpoint security. By keeping a close eye on what's happening on these devices, we can detect suspicious activity early on and take steps to mitigate potential threats. This proactive approach can help prevent incidents from escalating into major security breaches. Section 8. The human element, training and physical security. While technical controls are paramount, we must not overlook the human element in ICS security. Employees play a vital role in both protecting against and mitigating cyber threats. Comprehensive security awareness training is essential. Employees need to understand the importance of strong passwords, the dangers of phishing attacks, and the potential consequences of social engineering. By educating employees on best practices and promoting a culture of security, we create a human firewall that complements our technical defenses. Physical security measures are equally important. Access to ICS environments should be restricted to authorized personnel only. Surveillance systems, intrusion detection systems, and other physical security controls help deter and detect unauthorized access. It's also crucial to have a robust incident response plan in place. This plan should outline the steps to take in the event of a security incident, including communication protocols, containment strategies, and recovery procedures. Regularly testing and updating the incident response plan ensures that everyone knows their roles and responsibilities, enabling a swift and effective response to minimize downtime and mitigate damage. Section 9. Continuous improvement, the key to lasting security. In the ever-evolving landscape of cyber threats, static defenses are insufficient. Continuous improvement is essential for maintaining a strong security posture in ICS environments. Regular security assessments and penetration testing are vital. These exercises help identify vulnerabilities and weaknesses in our defenses, allowing us to proactively address them before attackers can exploit them. Staying informed about emerging threats and vulnerabilities is also crucial. Subscribe to security advisories, attend industry conferences, and participate in information-sharing communities. By staying ahead of the curve, we can anticipate and mitigate new threats more effectively. Finally, remember that cybersecurity is not a one-time effort. It's an ongoing process that requires vigilance, adaptation, and continuous improvement. By embracing this mindset and fostering a culture of security awareness, we can create a more secure and resilient future for our critical infrastructure.